Okay, so in this video, I will be sharing insights on measuring income inequality by focusing on what's known as the Lorenz curve, Lorenz, the Lorenz curve, and as well as what's called the Gini coefficient, Gini as in G-I-N-I, Gini coefficient. And I'll be discussing in this video their calculations and highlighting some issues with the conventional methods of measuring income inequality. There's, a lot of students and faculty struggle with the conventional methods of measuring, via the Gini coefficient. I'll also, probably express some of my personal opinions on the topic of income inequality, time permitting. But let's start off with the Lorenz curve. The Lorenz curve was introduced by Lorenz in 1905 in a paper, and it's a graphical representation that plots cumulative income against the population, and so it's ordered from the lowest to the highest income. And so this concept, though over a century old, is fundamental to understanding income distribution. To illustrate this, I've prepared a quick Microsoft Excel version of the United States income distribution. It's a simplified representation of the United States income distribution. So without further ado, let me go ahead and share my screen and share that with you. Okay. All right. So what we have here is the graphical representation, right? Let me just break it down for you. This is a simplified representation of a recent Gini coefficient for the United States. Very simplified. We are assuming that, for instance, if you look in column B, row 2, that the average income for one person or one group of people is $1 a year. Okay, that's obviously a hypothetical. Okay, that's not meant to be serious, but it's just simplified. And the number, actually, the Gini coefficient maps. So in column A, we have the cumulative population. It's broke up into what's called quintiles. Okay, you've heard of this before in other applications. Maybe when you were a kid, if you remember your doctor, your pediatrician saying you're in this particular quintile or percentile, right, of weight or of height. Okay, these are broken up into 5 quintiles. That just makes it really easy. So the first is the first 20%, the second 20% here, third 20% here, fourth and fifth. Final. The amount of income per group for the first quintile is $1 a year. The next group is 3, the next group is 5, the next group is 7, the last group and the richest group, okay, is $17 a year. If this is the richest group, then what do you think this makes this group? The poorest, right? The poorest group. And then obviously these would represent lower and upper middle class. This would be middle class. Now, that's all relative and just kind of high level, okay? This is how much percent of the income this group possesses. This is how much percent of the overall income this group possesses. This is how much percent they possess, so on and so forth. And then the cumulative proportion of income, okay, by each, it cumulative as in what it totals to. So that 3%, 3 plus 9 is 12, right? 9 plus 15 is 27, 15 plus 21, obviously 48%, and then obviously 21 plus 52, the remainder that is, or the 48 plus 52, rather. I did the math wrong there for you, but you can see how the numbers match up, right? When you add them up to 100 to cumulative, but you got it. Okay, so the Gini coefficient, right? Let's start with the basics. The Gini coefficient is, as you see in column M, row 1, okay, it's A divided by A plus B. So A divided by itself all over again plus B. So what areas are we talking about in this graph? Well, okay, we have a y-axis here and we have an x-axis here. Now, typically speaking, when you look at a Gini coefficient, this y-axis is actually going to be labeled right here where the cursor is. You can see how this says 100, ignore the 120, but the 100 here, this would be where the y-axis is. So just for, you know, imperfections of Microsoft Excel, right? It's over here on the left. But this line here from 0 all the way to 100, because that is 100, it's where the y and the x meet 100. This line here, this orange line, it's a linear curve, it's a linear line, right? That represents, listen up, that represents the perfect equality, the line of perfect income equality. This blue line that is nonlinear, right? It's further away, right, from the line of perfect equality. That is your Lorenz curve, okay? So again, because of Microsoft Excel imperfections, this blue line would normally extend all the way to the 0, okay? But it stops here, but let's assume that it extends all the way to the 0. Therefore, the space between the line of perfect inequality, the line of perfect equality, the space between it and the Lorenz curve, the blue line, that space is A. That is what we mean by A. Okay, so then if you take this line from 100, where 100 on the y and 100 on the x and 100 on the z-axis, here the line of perfect equality, all three intersect, and you draw a straight line down to the 100 here, and then a straight line over all the way to 0 here. The space between these two lines, x and the y and the x-axis, here and here, and the blue nonlinear curve representing the Lorenz curve, right? That is B. So if you take the Gini coefficient and you just look at it, you say, okay, visually here, A is that space up top between the line of perfect equality and the Lorenz curve, divided by whatever the sum of that space and the space below the Lorenz curve, A plus B. But if you don't know what that is, then you got to do some math. And this is where this calculation is better. You know, the conventional way that a lot of professors, a lot of instructors, you know, in high school and AP economics in high school, in calculus and Calc 1, I think, and some other classes, they have you find the geometric shapes, squares and rectangles and triangles. And I swore when I was in graduate school, I was never going to have my students do that. We're going to use this calculation here. Why? Well, one, it takes a long time. Okay. Two, there's a better way. Okay. Especially if you get into unequal spaces, which a lot of Lorenz curves can have. Okay. So the further this line moves away from the line of perfect equality, the more inequality you have. The closer it is to the line of perfect equality, the more income equality you have, right? Okay, so here's how we do it. This letter here is the Greek letter sigma, and the bottom right, it might be small for you to see, it says lowercase I equals 1, okay? And the reason for that is that we're talking about the first group, okay? And then N, as you can see in the legend down here, okay, N is the fifth group. Now we're going to change out I into each group in this equation, and you're going to see why here in a second. But in this equation, we are going to take 2 times I, and again, use this legend here, it's going to be each group successively. So the first group, the second group, the third, the fourth, the fifth. We have 5 groups. So we're literally just using the number of the group, right? So 2 times 1, right? You can see it down here. 2 times 1 is what? 2 minus N. N is the fifth group. So the number 5, right? Minus 1, okay? And then order of operations. So in parentheses, and then times X is the average income, and I put it in quotations, underlined, and italicized the watchword there. It's that group, the average income in that group. So we're talking about the first group, the first quintile. The average of 1 is what? 1, okay? So times 1, okay? The average of 1, all right? Divided by N, okay? N is the fifth group squared, right? So that is 25 times, and U is the average income of all the groups. So we literally take 1 and 3 and 5 and 7 and 17. We add them up, we divide by 5, and we get an average of 6.6, right? And so when you go each group one by the other, right? And you go to the next group. So 2 times the second group. So 2 times 2 is 4 minus 5 minus 1 times, right? In this case, 3. Okay. And then you do the third group, and that's 2 times 3 is 6 minus 5 minus 1 times 5, right? So on and so forth. And so in each case, you have to get the average income for that group. So what is the average income of the second group, the third group, the fourth group, the fifth group, right? It's listed here. The average income of the first group is 1. The average income of the second group is 3. Average income of the third group is 5, 7, and 17. So these are pretty easy to understand because, right, they are pretty straightforward and simplified, right? So here is how the math breaks out when you do all the calculations and the parenthetical references here. You got -4 plus -3 plus 0 plus 14 plus 68 equals 75. Okay, right? And then when you 75 divided by 5 squared times 6.6 equals 0.436. Now in the United States, it's actually sitting around about 0.46 right now in 2023. I think it's based off of 2022 data. But that's, a good simplified representation of income inequality. Now you can do this by town, you can do by city, by municipality, by state and regional area, nations. You can generate it. And it's important to remember that it is not a percentage. It is not a percentage. 0.43, 0.46. Not a percentage. It's a graphical visual representation. And there's a lot going on here. You can't just say, oh, further away from the line of income equality, perfect equality, bad or good. You can't just say that, right? There's a lot that goes into that. If everybody's poor and the average income is just poor and you have perfect equality, then everybody's equally poor, right? That's not a good thing, right? So there's a lot to factor in. There's also, which is the topic of another discussion, taxes, welfare, income redistribution, accounting for average income or not accounting for average income, things like that. So there's a lot to consider, a lot to factor in. It's not a straight, easy, closed-ended question and answer of whether or not the current Lorenz curve is a good. It represents something that is optimal, right? You think of like the Human Development Index, HDI, right? Standard of living, access to healthcare and education, all these kinds of things, right? It's not just straightforward like that. There's a lot to factor in. In fact, some economists argue that the 0.46 or whatever it is listed isn't actually a representation of the actual average level of income because of wealth and income redistribution via welfare, tax subsidies, and all that kind of stuff, and they're probably correct. So there's a lot to factor in here. It's not just straightforward. Anybody that tells you otherwise or says the goal is that line of perfect equality, be wary. It sounds like it might be more politically motivated than it is truly public policy and public policy economics. All right. See you in the ether.